The experiment begins with the setup of 3 clear cups. These cups are arranged neatly on a clean, flat surface. Each cup is then filled with water to roughly the same level. Maintaining equal water levels ensure a fair color mixing process. This careful preparation sets the stage for controlled observation. The setup is now ready for the addition of colors to each cup. Red is recognized as one of the primary colors in the traditional color model. Adding red food coloring to water demonstrates its ability to create a uniformly colored solution. The vibrant red colorant mixes thoroughly, illustrating the properties of a primary color. This mixing process visually represents how red can be used as a base for creating other colors. The resulting solution exemplifies the pure and intense nature of the red primary color. Yellow is introduced as a primary color. Yellow food coloring is added to a clear liquid, typically water. The yellow dye begins to disperse throughout the liquid. This dispersion process evenly distributes the color. The liquid transforms into a bright yellow hue. This demonstrates yellow as a distinct, fundamental color. Blue is one of the 3 primary colors. Blue food coloring is added to water. The water turns a deep blue color. This completes the set of primary colors for mixing. Secondary colors are created by mixing 2 primary colors. Red and yellow are primary colors. When red and yellow are combined, they create the secondary color orange. Pouring red-colored water into yellow-colored water initiates the mixing process. As the colors blend, the resulting mixture transitions towards an orange hue. The intensity of the orange color depends on the ratio of red to yellow. The solution starts as a mixture of red and yellow. As the 2 colors blend, a transformation occurs. The solution gradually changes to orange. This demonstrates the creation of a secondary color through mixing. The experiment demonstrates the combination of primary colors to form a secondary color. Red and yellow are mixed together in equal proportions. The mixture results in the formation of the color orange. The consistent orange color confirms that red and yellow combine to create orange. Green is created by mixing blue and yellow, which are primary colors. The process starts with yellow-colored water in a container. Blue-colored water is then added to the yellow water. The interaction and mixing of blue and yellow result in the secondary color green. The primary colors blue and yellow can be combined. Mixing blue and yellow creates the color green. Green is classified as a secondary color. This demonstrates the creation of a new color through color mixing. Color mixing is a fundamental concept in art and color theory. The presence of green confirms a color mixing outcome. The green color has fully formed within the cup. The color distribution is even. This even distribution indicates a successful mixing process. The confirmation process is complete. The scene illustrates the creation of a secondary color by mixing 2 primary colors. Red-colored water is introduced into a cup already containing blue-colored water. The combination of red and blue initiates a blending process. As the colors mix, they visually transform. This transformation results in the formation of purple. Purple is thus demonstrated as a secondary color derived from the combination of red and blue. Purple is created by mixing red and blue. Red and blue are primary colors. Mixing primary colors results in new colors. Purple visually demonstrates the combination of red and blue. Color mixing is a fundamental concept in color theory. The mixture now exhibits a uniform purple color. This uniform color indicates the successful combination of red and blue. The resulting purple hue confirms the creation of a secondary color. Purple is formed through the even distribution of red and blue pigments. The consistency of the purple shade demonstrates thorough mixing. This process illustrates the basic principle of color mixing to achieve new shades. Colors can be combined to create new colors. The proportions of each color affect the resulting color. Color mixing demonstrates a fundamental principle of color theory. Different color models exist, such as additive and subtractive mixing. Red, yellow, and blue are classified as primary colors. Primary colors cannot be created by mixing other colors together. They serve as the foundational base for creating all other colors. Combining primary colors in various proportions yields secondary and tertiary colors. Therefore, primary colors are essential and unique in color theory. Secondary colors are created by mixing 2 primary colors. Orange is a secondary color made by combining red and yellow. Green is a secondary color resulting from the mixture of blue and yellow. Purple, also known as violet, is a secondary color produced by mixing red and blue. Therefore, orange, green, and purple are classified as secondary colors. Each secondary color occupies a space between its constituent primary colors on the color wheel. A color wheel is a visual tool used to organize colors systematically. It illustrates the relationships between different colors. Primary colors are positioned equidistant from each other on the wheel. Secondary colors are created by mixing primary colors and are placed between them. Color mixing is a basic technique in art. It enables artists to produce diverse hues and shades. This is essential for creating depth and realism in paintings. Color mixing also allows for emotional expression through color. Artists use color mixing to achieve specific visual effects. Color mixing is a fundamental technique used in design to achieve desired visual effects. Designers use color mixing to create specific color palettes. These palettes are carefully selected to evoke particular emotions. Color choices also influence the mood conveyed in visual communications. Effective color mixing enhances the overall impact of a design. It allows for precise control over the psychological effects of visual media. Color mixing is essential for achieving accurate and vibrant colors in printed materials. The printing industry relies on color mixing to reproduce images and designs effectively. Precise color control is necessary for consistent and high-quality printing results. Various color models and techniques are employed to achieve the desired color output in printing processes. The textile industry utilizes color mixing extensively. Color mixing is essential for dyeing fabrics. It also enables the creation of diverse patterns. Color mixing contributes to the design of textiles. This process allows for a wide range of aesthetic options in textile production. A tint is produced by mixing a color with white. Adding white to a color increases its lightness. The resulting tint is a lighter variation of the original color. Tints maintain the same hue as the original color, but with reduced saturation. Tints are often used to create softer, pastel-like color schemes. A shade is created by adding black to a base color. This process darkens the original hue. The addition of black reduces the color's lightness value. The resulting shade maintains the original color's identity. However, it presents a darker variation of that color. Shades are useful for creating depth and contrast in visual design. A tone is created by adding gray to a pure color. This process reduces the color's saturation and intensity. The resulting tone is a muted version of the original color. Tones maintain the base hue while appearing softer and less vibrant. Color mixing is a fundamental concept. It has wide-ranging applications across various fields. These fields include art and design. It is also applicable to manufacturing processes. Color mixing is important in technology as well.